Hello and welcome to this tutorial video on Thunor Web. Thunor Web is a web application for managing, visualizing and analyzing high-throughput screen data. It works with both endpoint and time series dose response cell proliferation data, where it calculates viability scores and the dip rate respectively. In this video, I'm going to be going through the installation and covering some of the basic features of Thunor Web. I've previously done a quick 3-minute overview video, so I will link to that if you just want to see what Thunor Web is about, first of all. This tutorial can be followed along as well, so I will open up that site. So that's docs.thunor.net/tutorial. As you can see here, you can follow along with a written copy of this tutorial. And also, if you're interested in just trying Thunor Web out, you can do that as well. So demo.thunor.net, and then there's an online demo that's been preloaded with some datasets that you can try. So okay, so to start, let's do the installation. So the first thing you'll need to do is install Docker. So there's instructions for doing this here. Basically, in Windows and Mac, you can download a program directly from docker.com, so that's linked from this tutorial. On Linux platforms, there's an installation command that you can use, so just use your standard package manager. So since this is a Mac, I'll just show you the link, but I already have it pre-installed, so you go along here, install Docker Desktop, and download from Docker Hub, and basically it's just a standard Mac application that you can install. And then once it's running, you're going to see it in the task tray. It's a little whale type icon, and then when you click on it, you should see Docker Desktop is running, and then that shows that you're ready to continue on with the next step. You'll also need Python and Git. So Python actually comes with a Mac. On Windows, as does Git, I believe. On Windows, you would have to install those separately. So I recommend Anaconda for that. This is basically a Python distribution, Python and R, that includes a lot of useful software, and it includes a package manager that you can use, and you can just conda install Git and conda install Python. So I recommend checking that out if you don't already have Git and Python installed. Okay, great. So on to the installation steps. So in this tutorial, we're just going to install Thunor Web for single machine use. So this basically means it's going to run like on your laptop or desktop or whatever machine you install it on, but it's not going to be accessible for other machines. It's a web application, so if you want to use it across the network and have multiple users and collaborate, then check out the full installation instructions. To do that, it's actually very similar to this. You just specify a different host name here. But there's a link to those instructions. Okay, so to do the installation, I've actually got a terminal.app open here. So I'm going to go ahead and run this first command and copy paste that in and git clone. And you see it works relatively quickly. And then I can just cd thunor-web, and I'm in the directory ready to run the deployment script. So that is a fairly simple case of running this command. And that runs through, checks prerequisites, and basically does everything needed to start the application. You can see it checks for whether the database is ready. This is system dependent, so it may go through this cycle a couple of times, but eventually there we go, it's now ready, and it will start the database initialization process. So the database is ready, it's starting the application. And that's it. So you should see this message saying deploy complete. Thunor should be available at http://localhost, and you can create an account. So let's just check that it's up and running. So I'll just copy and paste that into my browser here. And there you go. So this is the screen, and it's as simple as that. So you see that that took less than a minute, I think, to run through the installation because I had it already downloaded. The containers are already on my machine. If you're on a slow internet connection, it may take a few minutes to download those containers, but it's still a very quick and automated process. So to log in for the first time, I actually need to create an account. So it actually gives me the command for doing this here, which is this create super user. And then I just enter an email address. Since I'm just trying it out, I can actually just enter anything I like. So I'll just enter thunor@example.com and create a password and type it twice, and that's it. So the super user has now been created back in the browser here. I can now log in. I just enter that username and password, and that's it. And I won't save that in the browser. So this is the screen you'll see when you log in. So now that we're logged in, we're going to go ahead and create a data set. So first of all, we actually want to go and get some data. So if we go back to this tutorial and we've done this login and homepage, then you see there's this download example. So we'll go ahead and do that, and I've now downloaded that in the browser. So I can actually go back. I'll close this because that was the demo site, so you don't want to get confused. I can now go ahead and click Create Dataset. I go ahead and give it a name, in this case HTS 007. Click Next, and then you just drag and drop a file to upload, and in this case I already have it in the browser, so it's very straightforward. And it goes ahead and processes the dataset. So this basically goes through, parses the file, extracts the cell count data, and calculates viability scores, dip rates, and fits dose response curves. So this process may take a couple of minutes. So there we go. Once it's installed, you should see success appear next to the file, and done written here, and that's it. That's basically complete. So I'll go ahead and close this download area, and we click Proceed to Plate Mapper. So this shows you the Plate Mapper annotation view. For this particular data set, it's actually pre-annotated, meaning that the cell lines, basically the layout and metadata for the plates has already been is uploaded with the file. Alternatively, you can actually enter it using this graphical interface. So there's actually several different views that you can use here. So this is the overview view, which just shows which wells have been labeled with a drug concentration and a cell line, or just a cell line but with no drug and not annotated at all, so unused wells. And you can actually switch to different views here. So this looks at the cell lines. On this particular plate, it's all one single cell line. There's multiple drugs here, and I can see there's a legend down here, and also I can just mouse over any of these wells and it will show me what the cell line drug concentration is. I can look at this concentration view as well, and look at dip rates. So I can see, for example, if there's like any wells that stand out because they have negative growth when they shouldn't, like control wells that had negative growth, for example. I can also view this in a table view, so I can sort by cell line, like so. So it basically allows you to inspect the metadata. I can also drag and select, and then if I wanted to change the cell line assigned to those wells, I can do that. So in this case, I don't want to mess this data set up, so I will not do that. This well allows you to select the whole plate, and you can also, select by rows, select by columns, that kind of thing, and apply the concentrations. Just to kind of quickly go over the other features here, if you were to be annotating this data set, you can annotate one plate and then copy those by creating a template, and click Apply Template, and it will copy that layout to another plate. You can use this auto stepper, which basically means if I have a selection, for example, let's do, say, write one well, and I have some selection, then when I enter some data, it will automatically shift this to the right. I can also do this manually. So I type in a concentration, press enter, and it moves on to the next one. I press enter. So it helps to expedite the data entry process. I can also import these and export these in these JSON and TSV formats as well. So if I want to reuse plate formats between datasets, I can do that. And to switch between plates in this dataset, I can do that just by clicking on one of these and it loads the next plate. So that's the plate mapper view. So to exit that, I click Finish. Now I'm taken to this Dataset homepage. So there's a variety of different options here. On the right-hand side, I see metadata, the user that uploaded the dataset, creation date, the most recent data upload, and the most recent change in data annotation. The plate map is what we've just seen. I can actually download this dataset in HDF5 format. So this is a compressed binary format that you can use if you want to switch this dataset around with different Thunor instances. And upload it, share it with a different lab or a collaborator, for example. You can also download dip rate and viability parameters. So these are TSV, so spreadsheet-like data, tab separated value, that will basically show you the fit parameters for each cell line drug combination, both for viability and for dip rate. I can add additional plate data to a dataset. I can also click Manage Permissions here. So if I wanted to make this particular dataset public and allow anyone to view plots on this dataset, I can do that just by toggling a switch. Okay, onto the plot system, which is really kind of the centerpiece of this application. So there's a quick start guide here, but I think it's hopefully fairly intuitive to use, but I'll give you a quick overview here. You click Add Plot, and a window, a panel appears, like this, and I can select different types of plots, so time course, dose response curves, a dose response parameter plot, quality control, and I can select any cell line, any drug in the dataset, and click Show Plot, and that plot is loaded. And these use a tool called Plotly. These are interactive plots. So I can see on the x-axis is time in hours and the change in log2 cell count from the time 0 baseline. I can resize these plots by, if I double click, I could also use this auto scale button, which does the same thing. And basically that scales the axes for me. And I can see the different concentrations on the legend here. Select one. It's called isolating the trace. So if I double click, I can do that, or I can deselect with a single click. So if I want to turn off the control wells, for example, and turn them back on, I can do that. There's lots of interactivity in these plots. This applies to all the different plot types. You can kind of pan. I can select a region if I so desire, and doing lasso select. Zoom in, zoom out, reset the axes to how they were originally, or auto scale, and change whether I'm showing all of these, or if I go show closest, it just shows a single one. So just to show you a few features on here, you can click on this change plot button. I can update this plot. I can click this duplicate button, and this actually clones this. So show this more easily, I'll switch to a 2-column view, and you see this automatically resizes, and I click clone, and I get the same plot again as you would expect. I can actually click this to open the plot in a new window. So this is useful if you were working with a dual screen layout, or if you just want to rearrange plots as you see fit. And download, so this covers images, so you can save the current plot as a ping image. So this is a bitmap image, SVG, which is a vector image, so this resizes without loss of quality. Plotly JSON, so this is actually the underlying plot data. If you want to recreate this plot, if you're familiar with the Plotly library, then you can do so. If you wanted to change, say, various style attributes of the plot and aesthetics, then Plotly gives you lots of customization. CSV, which covers the underlying data from the plot in CSV format, comma separated value, and HTML, which is saves the plot itself and the Plotly library all in one HTML file, so that you can basically have an archivable copy of a particular plot that preserves its interactivity. So I can go ahead and change this plot and go into change it into a dose response curve, for example, and now I'm seeing the dose response curve for this time course here. If I want to drag, I can drag on this gray area and rearrange these plots as much as I want. On this dose response plot on the left, we have multiple control wells. The x-axis value is set to 10x less than the lowest concentration in the data set because it's a log plot and it needs an arbitrary concentration value in order to show on here. But you can see these various dip rate values for each of these replicates on this plot. So these actually correspond to the gradient of each of these lines. So you can see that more clearly if I turn on the overlay dip fit option. And then to make this more clear, I can isolate a particular concentration. So a good one to pick is probably this 62.3 nanomolar concentration. We appear to be getting some quite wide spread between these two replicates, so let's take a look at that. And as you can see, the slope of these two lines is quite different. So this is one advantage of Thunor, that you can go through and look at raw data. If you spot some anomaly in the dose response curve or in one of the parameters that doesn't make sense, you can kind of trace back and then go through and look at the raw time course cell count data and then say, okay, well, there's no issue with the fit in this particular case, so maybe we want to go and look into those wells, maybe do a repeat experiment or something along those lines. And just to quickly show you, there's a variety of different plot types here, so I will show you how some of those look. So you can get a feel for this. I can plot multiple dose response curves. So if I'm interested in a beamer-cyclib, I can look at all 8 cell lines here and click show plot. And as you can see, I can view all of those dose response curves. I'm double clicking to resize the axes and then look at how those fit for this particular drug. So if I'm interested in metrics of those curves, that's under dose response parameters. So I can view, say, the IC50s of all of those dose response curves, and I can do that as a bar plot. I can actually, if I wanted to, select for the entire data set and then view all the IC50s. And although that's going to be difficult to read in the x-axis, the plotly interactivity means that you can scroll through and view what those combinations are. I can do color overlays on here, so I can go through and color that by cell line. Which is probably a bit crowded here, but if I deselect and move down to just, say, 5 randomly selected drugs, it makes it a little bit easier to see, although I would say probably no discernible pattern there, but not surprised given that it's randomly selected. Okay, so those are dose response parameters. So I can go through and pick another parameter. Let's have a look at Emax and view those. So there are several other options here. So there's bar plot if you're looking at a single parameter. I can also look at 2 parameters plotted together. So I can look at IC50 versus Emax, and that gives me a scatter plot. So I could do this for the entire data set. You can see a trend line is plotted. We get an R-squared value and a p-value. I can do the color overlay again by cell line. So depending on the data set, you may or may not see patterns, but those options are there. One other nice option, if I turn off this second parameter, is that I can view these aggregated. So if I wanted to see how these 27 different drugs are working across these 8 cell lines in aggregate, I can do that. I'm going to turn off the color overlay. And then this shows as a box plot. So for each of these drugs, it's showing me the range of Emax values in this case. So we've got the minimum, the first quartile, the median, the third quartile, and the maximum. And I can view this for each of these different drugs. So I can actually do... let's turn these on to separate. So I could do, so this is actually looking at the viability Emacs versus the dip rate Emacs. So I can actually compare these two as well. So I can switch between viability and dip rate or compare them head to head as well. Finally, I'll just quickly show you the quality control view. So let's do control dip rates by plate. So what this is showing is we have each multi-well plate is shown on the x-axis, and the range of dip rates on the control wells on each of those plates on the y-axis. So we actually have in this data set 2 plates for each cell line. And given that these are control wells only, i.e. no drug added, we should see that there's low variation, so small error bars, but also that there's, say, these 2 plates for the BT20 cell line show close concordance with each other. And as you can see in this data set, you get close concordance between close agreement between those 2 plates for each cell line. And just this is similar to what we saw in the plot interface, but you can also have a view here of looking at dip rates on the multi-well plates directly as well. Okay, so finally, I'm going to go through and show you the tag system. So I can actually navigate via this menu at the top, or by clicking on cell line tags. So I click on the logo and it takes me back to the home page. I'm going to click on cell line tags, and this shows me the tag view. So tags are essentially categorical labels that are applied to cell lines or to drugs. So these can be things like the cell line's tissue of origin, any particular mutations in the cell line. We could add those as tags. For drugs, they could be things like the target gene or target pathway, essentially kind of any categorical label you want to apply. So I will show this process. Again, if we go back to this tutorial, then there are some example tags. If I scroll past this plot system, which we've just demonstrated, then you can download some example cell line tags. So that's what we're going to do. Click on that. And if we go back to here, I click upload cell line tags. So there's this option, create cell lines if required. So if that's left off, which is the default, then if there are cell lines in the uploaded file that don't exist in the system yet, then it will show you a warning. So I guess I could quickly show you that there's these cell lines in the dataset don't actually aren't in the system yet. So we're going to go ahead and create those. And if I click upload to do that again, then that file has been uploaded. So you can see here there's 2 tags. These are tissue of origin, so they've got that category applied, and basically labeling a set of cell lines being labeled as aerodigestive tract or skin. So for each of these tags, I can click on it, I could edit which cell lines this applies to, I can change the permissions on it, so I can actually select and make this public if I wanted to, so that every user of this instance of Thunor can access those tags, or I can just keep them just for my own use. I can also select a set of tags. I can download them again, so again to share them with another instance of Thunor, or to open them in a spreadsheet program and use them in some other pipeline. I can do that as well. I can set permissions en masse, so if I have 100 tags, then I can just select them and make them all public in one go. And I should say about the permission system as well, just to note, it's not just public or not, you can actually create custom groups as well. So if you have multiple users that are working in different labs, you could add those as separate groups within the system and share datasets and tags with them. So you can also copy these tags. So if I wanted to create a skin and aerodigestive tract tag, I could just merge those and create those as a new tag. I can look at the intersections, so only cell lines that are going to be, in this case I would assume that there aren't any, but you know, if the tag is something like a mutation, then you could create the intersection to say cell lines which are mutated in gene A and gene B, and create that as a new tag. So analogous to cell line tags, there's also drug tags. These work analogously, so I'm not going to go through the upload process here, but you can basically do all the same operations on drug tags. So because I don't have a particularly large data set installed on here, we only did a small dip rate data set. Let's have a look at a large viability data set on the demonstration instance for Thunor. So I go to demo.thunor.net and I load this page, and I can see that there's these three data sets here, and I can see them because these have been made public by me, in fact, and I can click through onto one of these data sets, and as you can see, because this is a third-party data set, it has third-party terms applied, so I'm going to go ahead and accept those. I can click through into the plot system and I can do all of the same operations that I did on the previous set. So if I go on to those response parameters, I can see this is a much bigger data set, right? This is 1,074 cell lines, 250 drugs. So I could just go ahead and pick a drug. Let's have a look at tamoxifen. So this is looking at IC50 across the entire set. Because this is I've requested a lot of data, it gives me a warning. I can click show plot, and because of that warning, it might take a while to load. There are a lot of IC50s here. So yeah, nice thing about Plotly is I can actually zoom in and view like this. But to demonstrate the tag system, we go through onto the cell line tags, and you can see there's a bunch that are loaded here. If you want to try this on your own system, you can actually download these tags as well, and download those other data sets as well, so you can recreate this locally if you wanted to. But as you can see, there's all these different cell line primary sites that have been preloaded into the system. And if we go onto drug tags, we can see that there's some target pathways that have come from the GDSC as well. So, there's various molecular targets for these different drugs. So where those come in handy is that I can go into the plot system, I can create a plot, and then if I'm looking at it's most useful in dose response parameters view. But so one thing I can do is that I can switch. You can see there's names and tags here. So I can select cell lines by their name, but I can now also select cell lines by these tags. So if I wanted to select any lung related cell lines, for example, I can now do that. And I can select, maybe three different drugs, let's say. And let's plot that. So there's obviously quite a lot of cell lines there. So what I can do is I can aggregate, and then this will aggregate by those tags. So I can see the lung, non-small cell lung cancer versus small cell lung cancer versus the cell lines just labeled with lung. So I can just do that as a head-to-head. If I want to refine the plot, you can see it's very quick and interactive to change this. I could actually select all the drugs in the data set if I wanted to. You probably want to be a bit more focused in an actual analysis. Yeah, that's a bit difficult to read, isn't it? But I could actually view those aggregated if I want, so I can do a double aggregation. You can see this is a lot of data it has to crunch, so it takes a second to load. But yeah, I mean, these are not necessarily particularly biologically meaningful examples, but they give you an idea of the features that you can select and aggregate. So perhaps a more meaningful example would be if I selected a bunch of different pathways. So let's just choose a few that might be interesting. I probably want to switch this to aggregated rather than view each of those drugs separately. And then I can see, so in some of these cases you might start to see some more interesting data in that the drugs labeled as targeting metabolic pathways have greater IC50s. So that concludes this tour of the Thunor Web interface. I should mention as well as this web interface, this entire system is written in Python, and we provide a Python library which you can view at core.thunor.net. So this is called Thunor Core, and this has its own tutorial that you can go through and is basically a Python library that you can run with Jupyter notebooks. So this actually goes through and shows you that tutorial there. So in terms of further reading, you can go to the thunor.net website, and that covers the demo site, the documentation site, the source code for both the Python package and the web interface. We have chat if you want to talk with us, have questions about the system. And finally, kind of from a going further perspective, I'll go into the documentation, and as you can see, there's kind of comprehensive documentation on each of these topics. We cover the installation here if you want to do a multi-user installation. So that's basically this command here. So as you can see, it's a single command and it will deploy encryption and everything for you. It's all very straightforward, we hope. Another thing to be aware of is this configuration options. So this is essentially a bunch of changeable options for the administrator of a particular Thunor installation. You can allow public sign up, or you can make it invitation only. You can allow dataset access without logging in for datasets labeled public. So by default, a public dataset is, you still have to have an account to view it, but if you want it to be completely allow anonymous access, you can do that too. Entering an email server, so you can have make sure that user email addresses are verified before they're allowed. Integration with Sentry for logging and error tracking of the system, which is recommended in production. And here is a complete list of settings, the various configurable options that you can change if you'd like to further tweak the system. There's also this admin interface, which you can take a look at. So this is documented here. So to view this admin interface, I go to localhost/admin. And this is where I can add additional users. If I set up an email server, which I haven't done yet, then you can send invitations out to new users. You can view datasets on the system and add new accounts. You can also create user groups, so I could go ahead and do that now to show you. So if I create a group and I call it my lab, then I don't need to worry about these permissions. I just add my Thunor user and click save. So you can see it's as quick as that. I can go back into my lab, and I'm double clicking on these to add or remove particular users, and click save. And now my account is in the My Lab group, and I can see there's a My Lab tab here, which would show datasets associated with my lab. So if I wanted to do that and share this particular dataset, I can go through onto here, click View Plots, and if I turn that on and I go back to the home page and I click on My Lab, then I can see this dataset is now shared with the group called My Lab. So in addition to this admin interface, there's also this design and components. So this is just if you're interested in how Thunor Web works and the various components that went into building it. Then that's all documented here, the software tools and how the database works. But that concludes this tutorial. Thanks for watching.